Have you ever wondered why the switch on some of your appliances is different than other switches, or why do we have this box with wires going in and out? Well, in this episode we are going to answer these questions. These devices are known as miniature circuit breakers, or MCB in short. They are used for protection against overload and short circuit, and they have distinct mechanism for both the operation, which we are going to explore. This MCB has C16 written on it. Thus this is of class C with an overload current of 16 amps. Let's remove the rivets and open it. This is the input side. The phase wire is connected here. Then we have is a bimetallic strip. This strip is made of two different metals. When metals are heated they expand, and different metals expand at different rates. So when we heat two different metals that are joined, they bend, because one metal wants to expand more than the other. The heat to expand and bend can be generated by flowing a current, as the case in an MCB. Then we have is the movable contact. It is moved by the mechanism to turn on or off the MCB. The other part of the contact is fixed. Now from the fixed contact, the current flows in the solenoid coil. This solenoid coil is used to create a magnetic field that will push a plunger with a pin as required. Then we have is the output, which goes out to the appliances. There is also an arc or spark divider, which extinguishes the spark generated while separating the contacts. As these MCBs are used for protection against overload and short circuit, let us look at both cases. First, we will see the overload situation. When the MCB is on, the current flows through the bimetallic strip, and thus the strip starts bending. Its bending depends on how the strip is manufactured, thus different strips bend by different amounts for the same current. Also, the bending of the strip depends upon the heat generated by the current through it. This graph gives the time when MCB trips versus current through MCB. As the current increases, the bimetallic strip bends. The strip then pulls the small plastic part, and this moves the mechanism. Then the springs help to break the circuit, so the time to break remains small, and the MCB trips. As the circuit breaks, the current through the bimetallic strip stops, and thus it regains its shape. At the same time, a spark can be generated between the contacts. This spark can damage the components, and thus it needs to be extinguished as soon as possible. Hence, we have as a spark divider. The spark divider is just a bunch of electrically separated metal plates spaced with the help of insulators. This spark travels towards the spark divider from the contacts with help of these guides. The shape of the guide is designed such that the spark travels towards the spark divider. This spark can break due to the increased distance between the guides, but if it doesn't break, then the spark is broken into small multiple pieces by the spark divider such that they would not be capable of sustaining the spark for a long time, and it will be extinguished. You may also know that a spark is a plasma, and it produces a lot of heat. This heat can damage the plastic casing, thus we have a ceramic plate below and above it which prevents any damage to the casing. The spark divider also helps to dissipate the heat produced by the spark. Now, let's see the short circuit situation. In a short circuit, a large amount of current flows through the MCB. As the current flows through the solenoid, it creates a strong magnetic field. This magnetic field pushes the pin placed in the solenoid. The pin moves the mechanism, separating the contacts, thus the MCB trips, and the flow of current stops. A spark is also generated, and it is dissipated by the spark divider. But why do we need two mechanisms to break the circuit? Let's see for the first case, that is, on overload and the circuit breaker trips at 16 amps using solenoid as the trigger. Now as the current increases beyond 16 amps, just for a small amount of time, the solenoid will push the pin and the MCB will trip. And you may know that some appliances have power spikes where they can draw more current than their rated value. So we need a mechanism that takes time to trigger and won't trip the MCB during small spikes. Thus we have this bimetallic strip. This will trigger when a small overload is for a large amount of time, or a large overload is for a small amount of time. So why do we need this solenoid trigger, as the bimetallic strip may protect in a short circuit? Because the bimetallic strip takes time to heat up and expand, and during a short circuit, time is very important. A short circuit needs to stop as soon as possible, hence we have the solenoid to trip the MCB instantly. Now you know how an MCB works, but you need